Hello and welcome to the video presentation and demonstration of Anti-lockout Kit made by Not As of Yet team. The Not As of Yet team consists of 4 students from Cal State University Bakersfield: Gustavo Fuentes, Sahar Sharbov-Shor, Pascal Garcia, and Matthew Valenzuela. Each one of us will be presenting throughout the duration of this video, and the picture of the member currently speaking will be displayed on the bottom left of the screen. What is the Anti-lockout Kit? The Anti-lockout Kit is the combination of an online web application and the physical lock mechanism that uses facial recognition to unlock a vehicle. A user can create an account on the web app and register the lock mechanism that would be attached to a vehicle. Once logged into the web app, the user can simply push a button and use a device built-in camera to use facial recognition to trigger the lock mechanism to unlock. Why do we need this kit? This type of project is needed because it combines the already proven security of facial recognition with a physical object and will eliminate the need for a key. By eliminating the need for a key to unlock a car, we also eliminate the possibility of either losing the key or having the key stolen. These, combined with the fact that facial recognition is one of the most dependable forms of security, makes the Anti-lockout Kit one of the most reliable forms of preventing unwanted access to a vehicle. The Anti-lockout Kit would be targeted towards people with private vehicles and companies with company cars, because this would allow users to control who has access to their vehicles. In actuality, the Anti-lockout Kit would be a benefit to anyone with a car, but by limiting the target market, we allow the team to have a better focus on the needs of a specific group. We found several facts that show there is a good market for a product like Anti-lockout Kit. For example, according to AAA, about 4 million Americans lock their key in their car annually. The Anti-lockout Kit would be beneficial in this situation because it eliminates the need to call a car lock service, since it can make it impossible to lock your key in the car. The next fact is that facial recognition is found to be the best form of biometric security, as can be seen with the statistic of Facebook's deepface being 97.25% successful and Google's FaceNet being 99.63% successful, along with Apple's Face ID proving that facial recognition can be successful with private consumers by integrating it into its most popular product. Facial recognition has become profitable in the market, with expecting to garner $9.6 billion by next year. From here, we will be discussing the plan for the Anti-lockout Kit. Here we have a simple outline of our project's overall architecture. As it's shown, the user can use any smart device that is connected to the internet to access the Anti-lockout Kit web application. On the web application, users can sign up or log into their account, register their lock device, access their account information, change their account information, and delete their account. The web application push and pull from the database so that it can verify users' identity and store user information. The web application can access the device's camera to run the facial recognition system so that it can identify if the user's biometric measurements match the corresponding information in the database. If it successfully matches, Raspberry Pi will send a signal to unlock the car's door.
The database is written in the MySQL language and has a pretty simplified design. The database currently has 6 tables, each with their own unique purpose, designed in such a way that the queries and functions made for the A-LK can logically be made with little hassle.
Now, to better show how this is all done, it is here I will explain the functionality of the tables. First up, we have users. The user table is the cornerstone of the entire backend and stores their username, email, password, salt, and it is the table most called by the front end. The next table, the U-Access or User Access table, it is made up of 4 key attributes. 1, the Master ID. This one is the owner of the vehicle's ID. 2 is the Slave ID. It is the user given permission to operate a Master ID's vehicle. The third, the Mass Car ID. It is the car ID from the Cars table, which has been granted access to both the Master ID and the Slave ID. And the fourth, the Device. This is the device in the car from the Device table, which is currently being used by said car. And finally, there's the Authority attribute. This number allows the master of the account to set privileges to others whom they have given access via their account. Next up is the Device table. This table stores the device information of the unlocking A-LK that the user is using. The next table, the Logs table, this merely just tracks and logs the usage of a certain user via their ID on a certain car via its car ID. Next is the Face table, where it will store compressed facial data that is then able to compare multiple images denotated by the Who attribute, which is the user ID from the user's table. It also has the ability to date the images that come in as well, and can deem an image possibly too old to keep their current image up to date. And lastly, we have the Cars table. This one operates much like the user's table, in which it stores all the needed information for a user's car and denotes each row by its primary key, the car ID attribute. As shown, the A-LK is utilizing the feature of facial recognition. This will be accomplished by the use and implementation of OpenCV, the dlib C++ library, and the facial recognition library by Adam Gedege. OpenCV is a cross-platform library used for real-time computer vision applications with a primary focus on image processing, video capture, and analysis, including features like face detection and object detection. dlib C++ library is a library maintained currently by Davis King, which will be key to pulling off the learning aspect of the AI as it pertains to facial data. And finally, the face recognition library by Adam Gedege uses the dlib C++ library as a support to make facial recognition software work almost seamlessly.
Let me explain Plan Raspberry Pi. It is a mini computer with amazing capabilities. In order for us to make this work, we used an accessory called a motor driver Pi hat. This accessory allows for a motor or actuator to be used, due to the lack that the Raspberry Pi pins can only communicate and not power motors or actuators. The motor hat communicates with the Raspberry Pi through specified GPIO pins that tell it when to activate the motor, which is powered by the Pi hat that has its own external power apart from the Raspberry Pi. Now that you know the hardware that will be used, let me explain how the Raspberry Pi works. It starts by connecting to a phone's hotspot and is constantly checking the status of the database. There's a variable and table device called active, which will either be a 1 or a 2. Depending on the number, it will either mean unlocked or locked. When the unlock button is pressed, it will change the active variable to a 1, which means unlocked. And when the lock button is pressed, it will change the active variable back to a 2, which means locked. Every time the variable changes, it will activate the actuator, which will either lock or unlock the car.
Here, we will go over the graphic user interface. This simple diagram focuses on some of the different pages the user will interact with while using the web application. A user can either access the web application directly or through the website. From there, the user can either log in or sign up. Upon login, the user will be taken to the home page where they will be given the option to access the account info page, the user vehicle registration page, or unlock vehicle page. The user will also have the option to log out, which will return the user to the login page. On the account info page, the user will be able to see their information and also have the option to change their information or delete their account in its entirety. The vehicle registration page lets the user register the locked device that will be used on their vehicle to unlock said vehicle. The unlock vehicle page will access the facial recognition software that will trigger the lock mechanism to then be unlocked once a proper comparison of facial data is made. All of these pages
will be hosted on the vendor server provided to us by the illustrious Dr. Albert Cruz. With the plans we have for the database, the artificial intelligence, the interfacing device, and graphic user interface, the Anti-lockout Kit will have the following features. First, it will improve vehicle security by utilizing facial recognition software. It will allow users to register up to 4 vehicles per account. The GUI has been worked on to be easy to understand, easy to navigate, and easy to use. And the screens change dynamically to match the resolution of the screen of the device being used. Next, we will be moving on to the timeline of the project's completion. For the completion of the project, we decided to use the Agile Scrum method for our project management style. Scrum's methodology of meeting and discussing our progress, difficulties, and failures allowed us to plan and test parts of the project until we felt them ready to be considered complete. Its flexibility, it made things much simpler and easier to implement, especially trying to complete a project, one in which we cannot physically meet, as we currently find ourselves in a global pandemic. The A-OK team met at least once a week with the Scrum Master, Matt Valenzuela.
For the timeline, we broke up the development of the project into different milestones. The first sprint is to create the foundation of the web application. The second was to create and develop the database. The third sprint is to set up the Raspberry Pi to work with the lock. The fourth sprint is meant to create the connection between all previous sprints and test all the foundational functions. The sixth sprint is used to create the website for users to access basic information about the Anti-lockout Kit. And the final sprint is to modify an existing AI system for our facial recognition system. The first, second, and third sprint are to be worked on simultaneously by different members of the project. Each sprint is allowed about 3 to 4 weeks with the intention of adjusting the time for each sprint while working on them. For example, if sprint 3 is finished in 2 weeks, the remaining time meant for that sprint will be given to a sprint 4, which is expected to be more complicated to complete. For the implementation, the team was split up into 2 teams, the front-end development and back-end development. Pascual Garcia and Sahar Shabar Shore will be in charge of the front end. This means that they will be in charge of developing the user interface and creating anything the user will interact with directly. I, Gustavo Fuentes, and Matthew Valenzuela will be in charge of the back end. This means we will be in charge of creating the database and modifying the AI to work with facial recognition. In addition, I will also be taking on the task of developing the Raspberry Pi to work in the way we need to, and Matthew will be the project leader. While creating the Anti-lockout Kit, we did run into some challenges. The first challenge that we ran into was how we were going to host the application. In the beginning, we intended to create a smartphone app that can be downloaded from the App Store. However, we didn't have the necessary funds to do so. The next challenge was presented because of the change to a web application. The Raspberry Pi was no longer able to be connected through Bluetooth. Another challenge was connecting the application to the database. The project kept crashing when trying to push information onto the database during signing up. Part of this challenge was due to where the database was being hosted, from which leads us to the next challenge. The server that was hosting the database was not working with the server that was hosting the front-end code. Also, we ran into the challenge of having to use languages that we had little experience in, like PHP. To combat these challenges, we had to make a few changes to the project. Like previously stated, the first challenge was for the plan of making a smartphone application. It was changed to a web application that can be accessed through a smartphone. The next challenge was to connect the Raspberry Pi through Wi-Fi using a cell phone's hotspot instead of Bluetooth, so that the application no longer needs to be downloaded onto a smartphone and can be accessed through any device with a Wi-Fi connection. We also modified the database and moved it to the same server as the front-end code so that there would no longer be any connection issues. Also, because of the database modifications, we need to change the layout of the user interface to work better with the new database. Alright, now let's go ahead and start the demonstration of the Anti-lockout Kit.
For the video demonstration of the Anti-lockout Kit, we will be running the web application on a laptop. The web app is meant to be run on a smartphone, however it's easier to record the screen of the laptop, so we're going to be running the application here. Starting off, we're at the sign-in page, and we're going to go ahead and create a new account. Now all we have to do is click sign up. And after clicking sign up, we are brought to this page that lets us know that we need to check our email for a verification link. So let's go ahead and verify my email address. And clicking the link takes us to the login page to verify your email address. So now let's go ahead and log in. Once logged in, we are brought to this home page. And before demonstrating the home page, let's go ahead and click this hamburger icon menu, which brings up the other pages of the web app. If we go ahead and click account info, it brings us to the account information page where all of our information for the account is displayed. We even have the option to edit the information in the profile if we want to. But let's go ahead and go back to the home page. And here we can see the list of cars that we're able to register to the account. Because this is a new account, we don't have any cars registered at the moment. So when clicking on one of the options, it takes us to the register vehicle page instead of the unlock page. Here we can enter the serial number of the Raspberry Pi device that will be connected to the car lock. Once entered, we can click register vehicle, and now the vehicle should be registered onto our account. Currently, we only have one Raspberry Pi and it's registered to Gustavo Fuentes' account. But before we go over to Gustavo, let me go ahead and show you what the unlock page looks like once the vehicle has been registered. This is the page that you'll be brought to when clicking the vehicle that's already been registered. You can click on the lock icon to unlock the car, and if for some reason the facial recognition isn't working properly, you can still unlock the car by using your password. Now let's go ahead and log out. And now let's move on to Gustavo to demonstrate the Raspberry Pi working with the web application.
For the demonstration, we're going to be unlocking and locking the car using the Raspberry Pi. So right currently we're inside the car. We're on the Anti-lockout Kit remote access website page. So we have our two lock and unlock buttons. The Raspberry Pi is hooked up to an accessory wire inside the car, connected to the phone's Wi-Fi currently. We have the ground and signal wires running to the car down there in the wiring harness, which are the trigger wires for the lock and unlock. So now if we go ahead and we click lock, should lock the car, and it's a little slow so it may take a second. So right now the car is locked, and then if we go ahead and click unlock, the car should unlock. There we go, and now we're unlocked again. Thank you. In conclusion, we learned a lot from the project. The experience has not only taught us how to use the topics we learned in class, but how to implement them into an actual project. It has also given us first-hand experience and valuable skills that we have always been told but can only really be experienced in practice. For example, time management, pre-planning, and setting realistic expectations. Time management is important in anything, but in a project that lasts for an extended period of time, time management is extremely important. Pre-planning is also another very valuable lesson that we learned. In our excitement to start the project, we rushed through the pre-planning. This was a mistake. It added to the challenges we already had, where ideas needed to be changed because the plans were vague or unclear. Finally, setting realistic expectations was another lesson we learned. For example, setting a realistic time frame to complete tasks. Setting realistic expectations is important because setting goals that are achievable keep motivation up, while failing to complete a goal that was unachievable decreases motivation.
For the future of the project, some of the team members would like to continue its development. These members would like to perfect the features that already exist in the project, along with creating new ones. Like maybe even creating a feature that allows the engine to start with facial recognition along with the car unlocking. And with that, we are brought to the end of the video presentation. Thank you for watching.